Hello friends, welcome to follow up. Let's have a look at problem 59, Spiral Matrix 2. This is today's daily challenge problem. In this video, we're going to explain again the solution based on rotation matrix. So the problem asks us to fill with elements for matrix n matrix given the elements at least from 1 to n squared inclusive. So here the set of elements should be in spiral order, like in the clockwise fashion. So here is one example, right? We have 9 elements. So we first set 1, then move to right, set 2, set 3, then move down, set 5, set 6, set 4, set 5, then to the left, set 6, and so on. So each time the direction changes by 90 degrees clockwise. So example 2 is a special case because n is 1, so n squared is also 1, so there's only one element. The constraints for this problem, actually it's just one item. So here n is bounded above by 20 and bounded below by 1. So with that said, basically we are ready to do the analysis. So this problem actually is a follow-up for problem 54. So this problem is set matrix element, given elements. Well, for here, let me change. Well, for problem 54, so it's traversing the traversing the elements given the matrix. So the processes are essentially reversed. So we could use the same idea as in problem 54 to address the problem here. So the methods are the same. So both are rotation matrix methods. So here during traversal, problem 54 is for visiting an element, but here we are for setting an element, or we need to track the incremental direction, right? So if we assume dr dc is the current direction, so we can regard this tuple as a column vector. So after rotating 90 degrees clockwise, so the new direction is dr negative dc negative dr. So this can be easily computed by this rotation matrix. So given by 0, 1, negative 0. Then if you do matrix multiplication with dr dc as a column vector, so we're going to have dc negative dr. So here T means transpose. So the rotation matrix here, this one, or here, so corresponds to A equals negative pi over 2. So negative means clockwise. So for the general rotation matrix given by cosine A, negative sin A, cosine A, for counterclockwise rotation of A radian degree, right? So with this change of direction is the main point for this problem. So once we realize this point, we can write a while loop to set all the elements, because we know a priori we need to set n square elements. So with that said, we are ready to do the coding part. So first I'm going to initialize a two-dimensional array. So for a dominant index from range n, right? So this gives us an n by n zero matrix. Then we are going to traverse the matrix and actually then reset the elements. Actually, if we regard it like this, so this problem is reduced to problem 54, or we can say it's reversed with quotation mark. So now let's first record the current direction as 0, positive 1, right? If we walk along the first row, so each time we increment the column index by 1. So then also we need to use a visited. This is a set. So this is used to avoid repetition. And then the count, we are going to start from 1 because we set the element from 1 and to n squared, both inclusive. And then the current position is 0, 0. Next, we are going to do the while loop. Well, here we use count less than or equal to n squared. So because we want to set exactly n square elements. So you can think of this n as 1. So then if n equals 1, we need to do one set, right? So we need to do this even when count equals n. So that's why we have less than or equal to. So now once we haven't finished setting all the n-square elements, so we're going to set the current position to be the count. So in other words, the count variable plays two roles. It appears in the stop condition in the while loop, and also it's the value we want to set at a position RC, right? So once we set this element, so we're going to add this position to the set, and then we're going to increment this guy by 1. So after we set this RC position, we need to set the next position. So let's try. The next position will be R, dr, C plus dc. If this is still inbound or without the need of position change, let's check this. If R plus dr is less than 0, or R plus dr is greater than or equal to n, or this guy for C is less than 0, or C plus dc is greater than or equal to m, right? Or R plus dr, C plus dc invisited, right? So in this case, we know we need to make a change of direction. So how do we change the direction? So which is exactly the rotation matrix comes into play. So here we are going to set dr dc to be dc negative dr. And then afterwards, as we did the change of direction, now we can do the increment. R incremented by dr and C incremented by dc. So after we exit this while loop, we have finished setting of these n-square elements. So we just need to return the state of the result. So this is the full code for this problem based on the rotation matrix method and using this format of representation using a while loop. So before we make further comments, let's first do a check. Yeah, it passes the first example. So now let's look at the generic case directly. Yeah, it passes all the generic cases. So I guess with that done, that's basically about it for this problem. So you can try to follow up other videos in my channel, or in particular we have a playlist for the problems related to spiral matrix or rotation matrix. With that said, that's it for this video. Thank you.